Welcome to the first video on recursion. Recursion is a math process, and my definition here is that it's the process that occurs when a method calls itself. So remember, a method is a little mini program that we write on our own. It's kind of on the side, and whenever we want it, we call it. And when we have methods that we call, we need to send it some information typically. But this time, when my method runs, my method at some point in time calls itself again. And so what happens is you kind of end up in this loop where a method needs itself. And then when it goes to itself, it needs itself again. So a classic example of recursion in mathematics is the factorial idea where you need to figure out what 5 factorial is. And if you've never seen that before, it basically just means start at the number 5 and then multiply by all the other numbers below it till you get to 1. So 5 factorial is 5 times 4 times 3 times 2 times 1 all the way down to 1, and that equals 120 if you multiply it out. But in programming, factorial can really be represented as recursion. But in order to understand that, we have to think of it slightly different. And so what we need to think of is 5 factorial. When you want to calculate 5 factorial, you actually can do the number 5 times 4 factorial. Because remember what 4 factorial is. 4 factorial is 4321, and so it's another factorial. And then, of course, if we want to find 4 factorial would be 4 times 3 factorial, because that would be 321. And so the main idea here with the programming and recursion is, in order to calculate a factorial, we can take that number and multiply it by another factorial. And we could take that number and multiply it by another factorial. So factorial is using another factorial to find its answer. That's kind of the idea of recursion. And so, in general, if you just wanted letters instead of numbers, to find a factorial, you would take the number n and you would multiply by the next lower number factorial. And that's the idea of recursion. So to get to factorial, we multiply by another factorial, and we are now in this loop of factorials. And so here's a method and a little program that would calculate factorial for you. And you can see our main method here at the bottom. We have our main method that calls factorial 4. So basically it says, hey, go up to my factorial method, my little mini program for factorials that I wrote, and send it the number 4. So the number 4 gets thrown in up here, and it is now the integer a. So a is 4. And we go into our factorial method, and it says, hey, if a is 1, return 1 for me. Well, it's not, it's 4. So we go down to the else, and it's 4. So we return 4 times factorial 3. So here's what happens. When I go factorial 4, it's down here in the else statement. It says 4 times factorial 3. Well, guess what? This factorial 3 statement says, oh, I gotta go back to my method again, factorial 3, and I'm gonna send the 3 into that factorial function. And it begins to do this. It says, well, to calculate factorial 3, I jump in here, find out what to do. Oh, I'm right here. It's 3 times factorial 2. And so this factorial 3 becomes factorial 3 becomes 3 times factorial 2. And guess what? Factorial 2 says, oh, now I got to go calculate this thing. It throws 2 into my method, and 2 goes in, and it spits back 2 times factorial 1. Well, guess what? I got to do factorial 1. So I jump all the way back over here, put a 1 in, and now I finally get a different result that says, hey, if it's 1, just tell me the number 1. And notice it doesn't call itself again. So this looping process is done. And now I've actually finally constructed this whole factorial problem that's looping and using itself, which is called recursion. And I'm ready to calculate the answer. But one of the most important things to realize is how Java compiles this and how Java puts this answer all together. Now with the factorial problem, you can misunderstand this and still get it right. In the next problem that I do, or in the next video, it is very important that you understand this because you will not get it right if you do not understand this. So here's what Java does. It builds it backwards. Backwards means it starts at the end of this and it calculates the answer, which is the number 1. It takes that number 1 and it dumps it in for factorial 1. So it's building it backwards. It says that answer is 1. I will dump it in there for you. It calculates this number 2. It says, hey, factorial 2 is equal to 2. It's going to dump that into factorial 2 for me. It will calculate 3 times 2 is 6. It'll say factorial 3 is equal to 6. And it will dump the 6 into factorial 3 above it. It's building backwards. And now it says 4 times 6 is 24. So factorial 4 is 24. And it will spit out the correct answer of 24. So that's a good first example that a lot of people will use when it comes to factorial because it relates to mathematics. It's a good example and it's not too complex.